Okay, so we've been talking about nth roots and rational exponents. So now we're going to be simplifying some radicals. We've done it before with square roots. Now we're going to do it with cube roots, fourth roots, fifth roots, and things like that. So we've got two properties that could help us do this. Break up square roots to make them simpler, or fourth roots, fifth roots. We've got a product property and a quotient property of radicals. So the product property of radicals right over here says that if I have the nth root of a product on the inside, you can break that up as two separate nth roots. What that'll allow you to do is maybe you can take the nth root of the a part of it, maybe that's a perfect nth root, you can write that number down, and then you've just made your answer simpler. Okay, so the same thing over here on the quotient property. You can take the nth root of a quotient and break it up as two separate nth roots, as long as b is not 0, because we don't want to divide by 0. Okay, so remember, well, here let's try this on exercise 3. Should be not too hard right up front here. So just illustrating those properties, we can bring these both together. This is that property, the multiplication property going backwards, and make this the cube root of 12 times 18 on the inside of a root. So 12 times 18, let's see, that's 36, 0, 1, 8, 6, 1, 1, 216. Cube root of 216, which is 6. You know your perfect cubes by now, right? Okay, over here on number 2, it's using the quotient property here. So I can condense these things down, put them underneath the same fifth root, and make this 96 divided by 3. So that's the, that is the fifth root of, that goes in there, 32 times, and the fifth root of 32 is 2. Okay, so they're not always going to work out nice and simple like that, where it's a perfect cube or a perfect fifth root. So instead, we have to learn how to simplify them when they're not. Okay, so this is taking us back to simplifying square roots. Okay, so first of all, simplifying square roots, what we said is can't be a radical in the denominator. That was the first thing. We didn't like it. It's an old rule because it was kind of hard to divide by a square root, but it's a rule that kind of stuck around, so we still do it. So then the other one is that you can't have a perfect square factor inside the radical and it still be simplified. So you have to pull that thing out. Okay, so that's square roots. The same thing is going to be true if it's nth roots. I don't know why it's animated again, but there you go. So on the nth roots, the radical, you just can't have a perfect nth factor. So if you're taking the cube root, you can have a perfect cube on the inside. You can't have a perfect fourth root if you're taking the fourth root. Okay, so let's look at this two different methods if I'm trying to simplify the cube root of 40. So the first method is just trying to factor out a perfect cube. So I look at 40 and I try to think of a perfect cube that divides evenly into 40, like 8. Of course, you know, that's the drawback on this one, is are you going to be able to find a perfect cube root or a perfect cube number that's going to go into your number pretty easily. Okay, so now using that product property, you can just split that apart as the cube root of 8 and the cube root of 5. The cube root of 8 is 2, and then you just bring down the cube root of 5. I don't know why there's an equal sign on that at the end of it. Okay, anyway, so the drawback, like I said, is that you have to know your perfect nth powers, like your perfect cubes. You have to know your perfect fourths, and you know, most people just don't know those. Okay, so here's the second method, probably the preferred method, and that's using the factor tree. So over here on the cube root of 40, just start factoring. It's even, so 2 goes into it. So 2 goes into it 20 times. 20 is even. 2 goes into that 10 times, and then, well, still even, so 2 times 5. Okay, since this is a cube root, I'm looking for perfect cubes. Perfect cube is going to be 2 times 2 times 2. I'm looking for a triple of that factor. So I'm going to pull out that 2. It gets to come out. The 5 is left all by itself. So it has to stay inside of the cube root. Okay, so I still get the same answer. This one is, I think, preferred just simply because you don't have to try to think of perfect cubes or perfect fourth powers or whatever. You can just get it from the factor tree. You're just counting up your factors. So when using this method, you're looking for in groupings of factors. So if it's cube root, you're looking for 3 of them. You're looking for triples. If it's fourth root, you're looking for quadruples, and so on. And those come out as single factors. Anything that's left behind has to stay on the inside. If they don't reach up to the perfect cube, then they have to stay on the inside. If you have more than one, you have to multiply them all together. Okay, so let's apply this right here on exercise 4. I'm going to simplify the cube root of 104. I would prefer to just do this by making a factor tree. So it's even, 2 goes into it 52 times, and then 52, still even, 2 times 26, and then 2 times 13, and 13's prime. So I have 1, 2, 3 of them, and I'm looking at cube root, so that 2 gets to come out as a single factor, 2 cube root of, and then 13 has to stay on the inside because it's a lonely, lonely, lonely factor. Okay, so on the number 2, you don't have to multiply those 2 numbers together because you're going to have to make a factor tree of the final product anyway, so why don't we just make it with the smaller numbers. Like, for example, this is 9 times 3, which is 3 times 3. And over here on 6, I've got 3 times 2. Let's count up all those factors of 3. I got 1, 2, 3, 4 of them, and I'm talking about simplifying a fourth root. So that means that 3 gets to come out as a single power, a single factor, and then the fourth root of 2, that has to stay on the inside because it's all by itself. If there was another factor of 2, then they would have to be both on the inside and you'd have to multiply them together. Alright? So why don't you try this on exercise 5. Simplify both of those nth roots and then come back and see me. Alright, so let's conclude this video by checking your work. Okay, on the first one we're looking for the simplified form of cube root of 24, so make yourself a factor tree. There are 3 factors of that 2, so that 2 gets to come outside of the box, and then the 3 has to stay inside, so 2 cube root of 3. Okay, so here on number 2, still making factor trees. Yeah, and I get 1, 2, 3, 4 factors of 3, so that 3 gets to come out because it's fourth root, and that 2 is all left alone by itself on the inside. Okay, so in the next one we're going to be rationalizing the denominator.